Hello and welcome to TidyX episode 12. TidyX is a screencast where we go through and try to explain how code works for R. Alright, so my name is Ellis Hughes. I am a statistical programmer at Fred Hutch Cancer Research Center.
Hey, my name is Patrick Ward, and I do data analysis in sport. And you can find the both of us at tidy.explained@gmail.com.
Alright, so Patrick and I are super excited this week because we actually have a guest explainer this week, and it's Thomas Mock.
Hi. Yeah. So thanks so much for bringing me on. Yeah, it's so much fun to be on here. I've been watching the screencaster before. Obviously, pretty involved with the Tidy Tuesday group, and great to be here and actually be engaged in kind of following up after a data set goes out in the wild. A lot of the time, once it's like kind of out there, I don't revisit it for a long time, so it's nice to revisit it in kind of short duration.
Super. All right. So as he alluded to, this week's data is a fun one. I know I had a lot of fun going through it and seeing the submissions this week, but it was on cocktails. So they got a lot of recipes from several different locations. It was available through Kaggle. And so, like we said, there were some great submissions this week. But the one that we picked is from Joshua. As you can see, he's got a great plot here of the alcoholic and non-alcoholic top 10 ingredients, so how much was used for each one of these by total ounces. I think it draws some interesting ways, but what we thought was really interesting about this was actually a lot of the cleaning that he did as part of this processing. So his code, he provided a link in the Twitter post. So this is the link here, and now we'll start going through the code. So I'll bring it up here. All right. So we've got a clean environment for us to be working in. First thing to note is that he's working in an R Markdown document, which is something that Patrick and I always suggest doing. It just makes it really easy to organize everything. You can put, your text explaining your thoughts exactly with your code. But he also has a different output than we're used to seeing. Normally we do an output to HTML. He's doing an output to GitHub document. And what this will do is it'll make a nice output that when you upload to GitHub, it's going to render nicely in that format. And so that's a really cool benefit of outputting like that. The thing that we also thought was really nice was he listed at the very beginning all the packages that he intends on using. So this is a benefit. So anybody that's coming in and just reading through his post, they'll immediately understand which packages they're going to be needing to install if they don't have them already in their R environment.
The one addition I would say to that is I love when people make their own packages for stylings and things that they like, but it's always super helpful if you're going to share it out to the world, if you include the link so that people just have it, can upload it, and be ready to go rather than trying to dig through and find it.
Yeah. So this, if he put something like this here, that would have been really useful for us, because otherwise we had to go through and find it. Not a big deal, but that would have been a benefit. Then additionally, he's loading in this GG text library, which is a super cool library by Klaus Wilkes Lab. But that's not on CRAN yet either. So we had to go and search that one out. And that's available on GitHub. So, all right. So he loads in Tidyverse, GG text, patchwork, janitor, Delab J. Hopefully I'm saying that right. That's his package, and then forecasts. And then he loads in the data. So let's run that. Give my computer a second. It's going through there.
Yeah. While those are all loading, I think that part of the reason why I really found this one interesting was, again, all the data cleaning. For most of the weeks, like we select a data set that's pretty clean and kind of ready to go for graphing or visualization. This one was very intentionally left much more in a rough state. And it was really cool to see people actually taking time, go through and do some of the kind of like hard work of data cleaning and, preparing and diving into the different levels.
Exactly. So, yeah, to that point, he has this little comment here saying the data's pretty messy. Highlighting it, So he does a glimpse on the field measure from the cocktails data set, and this is just showing the different types of measures that are available. As you can see, there's some consistencies: quarter ounce, quarter ounce, but then there's like 1 ounce white, 1 ounce, half ounce, 16 ounces. So those are all over the place. Those are strings too, so you're gonna have to deal with that later on too if you want to really work with that sort of character data. He also does a summary on ingredients. He also converts it to a factor. I'm guessing this is so that he could then have it list the top used ingredients, because then it'll order it for you when you use summary. So vodka, is the most common cocktail ingredient. Not too surprising, I guess. Vodka is a great base for a lot of cocktails. Then gin, and then sugar. So, all right, cool. So next, he gets into, all right, so he does a bar chart. So he takes the cocktails data set and does a group by and says, okay, group by ingredient and do a count. So this way he'll get an individual count for each ingredient, so the number of times they appeared. So kind of what he did here with the summary as factor. But then he's gonna keep any cases where n is less than 2. So this tells you there are, and he actually puts it in this comment up here, that there are ingredients that only appear one time, and he plots it here, which he only meant to look at this part, or try to. Apparently my computer is struggling. But this is an example of when you have too many factors and your plot is just hard to read, and I think he does comment that here. So, all right, we'll move on.
Yeah, something kind of that I always forget, and this kind of reminded me, is with count specifically, the way that it works, you can actually pass the ingredient directly to it. So you can actually, instead of doing group by count, you would actually just do count ingredient. That's always really helpful, because like that's part of the use of count versus say like something like tally, is you can use it as like a group by count. It'll do all that for you.
Yeah, so you could do that.
Exactly.
Cocktails count.
I wonder why the x-axis came out on that plot in such weird numbers. Shouldn't it be whole numbers of 1 or 2 if it's a count?
Yeah, I think that the only observation would be n equals to 1, because it's a less than 2. Unless there is like a 1.5 in there.
Always. Oh, okay. So it just it picked an x-axis that made sense relative.
Right.
To that.
Mm-hmm. He also didn't add he also didn't add a geom to it. So it's just the GG plot there. So if you did like
sure, then
geom point, then it would have
now it would
have added that in there.
Maybe produced something. Yeah. Right. Got it. Yeah. Interesting.
All right. Cool. So now he starts with the data cleaning. And he does. So first, he converts ingredients to lower, which is a thing that I know I do a lot when I'm dealing with strings, and that's just to make sure that everything is going to remain the same string. So a capital. You can just look at it here. Jack Daniels. You could. I guess I'm just picking that one, but it could have a capital J, it could have a lowercase j, an uppercase D, a lowercase d, and those would all be considered separate ingredients, because as far as R is concerned, they're not the same string. And by calling a to lower on it, that'll convert them all into the same string, which would be all a lowercase j and a lowercase d. Mm-hmm. And that just makes your life easier. It's better for grouping for that situation.
Yeah. The other part I think that's interesting is like doing that in reverse is sometimes you get fearful of like taking everything to lower, because you're like, oh, what if I have multiple words? There's helpers and stringer, like string to title or string to sentence, that will capitalize only specific parts. And so you can do that all without regex, even though you could probably do it very easily with regex, but I always default to just like string to title to get everything back to uppercase on specific words.
Yeah. Yeah, that's a good idea. That's a good point here. I don't think I've used that before, but
you'd use it with like names, like
for Jack Daniels.
Like data analysis on athlete names or something. Mm-hmm. Guys who have like initial like DK Metcalf, right? It would it'd be like D lowercase k capital M. You can get all kinds of weird things sometimes unless you specify.
Yeah. So here he's doing the same sort of thing he was looking at in the plot before. Where he's just trying to find what are the ingredients that only appear once. So you see like absinthe, absolute pepper, ale, almond, Aperol. I'm not too hurt about that. I don't like Aperol. Don't tell my wife that, she loves it. All right. So next, what he does is, Thomas, why don't you take us through this piece here?
Yeah, so for both this and kind of in the little lower section, we're doing a lot of matching. So GSub basically takes the vector. It says if you find fresh inside ingredient, replace it with a blank. And the way that GSub works, which is part of base R, is it says match, replacement, and then the vector itself. So ingredient is actually the column name of the vector. And then lower, he actually uses a string replace, which is essentially the same thing, but through stringer. So for all of this, just kind of going through and grabbing a few of the kind of manual steps you need to do. Is like if it's Tropicana, we're just looking for orange juice because it's Tropicana orange juice. And if you misspell whiskey, we're looking for whiskey. So a lot of fun little manual steps here that are very helpful for like cleaning up the data, but are a lot of typing for sure.
Yeah, we were thinking about this. We couldn't think of necessarily an easier way to do this. This is just something you're probably just gonna have to sit down and find all the cases where there's spellings that are different, and just fix it yourself.
Yeah, there's some interesting stuff with like doing fuzzy joins, but that's really more for like partial misspellings. And for a lot of these, it's actually removing entire words. So I do think that this is kind of like a good approach to it for solving the problem.
Yep. Yeah, and then this final step here, he's doing an str trim. And I believe what that'll do is it'll remove extra white spaces from the beginning and end of each string. So that's like, for example, if you had the character space, hello world space, what it'll do is it'll now remove those two spaces I put there in the beginning and that one space that I put there at the end for you. So you don't have to go through and go, okay, how many spaces, how many white spaces do I have? And it's not just spaces too. Like you could have a tab character, you could have a lot of different types of white space that exist that str trim will just take care of it for you. So I know that's a super helpful function that I know that I use a lot too.
For sure.
Yeah, big time.
All right, so let's clean that up. All right, so now let's run this line, or this chunk. And now he does a quick group by ingredients and get the count, because that way you can try to identify cases that were still spelled incorrectly or had similar spellings that only showed up once. So you could match them. That's, I think, what he was doing earlier. And it looks like he's happy with those right now, so then he puts in this great comment here, I have an idea for cleaning up measurements, and so he'll use grepl to be doing that. So next he loads rlang. It's okay to have it here, would be nice to have it at the very top so that we knew that going in. Patrick, do you maybe want to talk about what's going on here?
Yeah, sure. He's doing a massive amount of K-swens here. Basically searching for, inside each grepl, he's searching for each of those little tags within the measurement column. And then he's identifying those as some sort of specific unit that he wants in the output in a new column called units. So, for example, kg, if it's in the measurement column, make sure in the units column it's called kg. And he'll do this, probably 15 times, 20 times maybe across, all the way down to the bottom, where he then gives you the true tilde units, which basically is anything else left over that isn't in one of those K-swens, just take it and replace it. Otherwise, if you don't have that, you'll have an NA in that column. We talked a bit about this. That's one way to do it. You could have had like a table of metadata that you just kind of joined in. It just depends on like sometimes I think for things like this, when you don't know the data set, when it's just dumped on your lap, you're sort of working through these ideas in your head as you type them out. If it was maybe something that you were working on a project with a domain expert where they have, known information, for example, like like let's say you're doing research on medical records, you could be looking at doctors' files, like notes, and one doctor might write fracture with a capital F, one might write it with a lowercase f, one might abbreviate it FX, capital F, lowercase x, lowercase fx. There could be a million ways to do this. Sometimes sitting with a domain expert and creating a table of some metadata that you could just load in with everything else and do a quick join sort of saves a lot of time and heartache.
Yeah, I think the other part, and I don't think we talked about this, was I think the efficiency would actually improve in terms of computation time then as a join, as opposed to doing multiple matches. Because I know if it's a large data set and you're doing 20, 30 string matches, that can probably take a while, as opposed to a join.
Yeah.
Then the other thing I think is helpful here is, if you're consistently typing like grep, in this case grepl, the word you're looking for in measure, you could probably define that as a shorter function. So something like grep measure. So you have it all kind of like squished together. It really doesn't save that much typing, but you could imagine a case where it was like grp ms, and that's grep measure, and then you're saving all this typing for your own personal use.
Yeah, so you don't have to retype this entire thing. It'll be
right.
grep measure can, and
exactly.
You just know that going in. Yeah, that's really nice. I realized we talked about this earlier. I think I realized what he's doing is he's trying to keep all the cases where can is can. He's not renaming them. So another potential thing that you could do is you could define a set of cases where you know that you're not going to be transforming them, and then just be like, when measure is in the vector of values, return measure. And that might have saved him some time too.
For sure.
Because that'll just then return that same exact value without transforming it. I mean, clearly this worked, and this way you really get a really in-depth knowledge of the data set that you're working with, and all the potential values that exist.
I think the last thing that I really appreciated here is how he separated out and aligned everything. Like, that does a lot for making this really readable. And so if you did hand this off to somebody and they're just like, what the heck's going on? Like, they can kind of see like, oh, this is really all just the same column. So it's easy to parse through quickly.
Exactly. And then there's this last little measurement here that's converting this this character here that's encoded as a half. So this is just one little character value there. It's converting it into 0.5 for ease later on, because this wouldn't be handled very easily. It'll be its own unique representation. So then he does some str replaces here, where he's doing additional cleanup with the measure, trying to convert them to be consistent values. And then at the end of the day, he does it for every field that is a character, replace any NA values with a blank, so an empty string, and he assigns it to clean 2. So he's doing this this unique write assignment, which isn't something that you necessarily see super often. It's nice when you're working with pipes and you're like, oh, I need to output this and save it. Write assignment to a vector or to an object. It's nice to have it to be listed at the very top so that you don't have to read through all of it to see what it's being assigned to. But this still works.
Yeah, I think one more thing on that is if you're ever doing like gsub and finding something and replacing it with nothing, or doing the same thing with string replace, that's what str remove does for you as well. So that's kind of a specific version of str replace to like actually remove it out. So it's the same thing as gsub, take something, take it out completely.
Oh, interesting. I've never used that one before, so I'll be looking for that one in the future.
Yeah.
All All right. Thomas, I know we talked about this for a little bit. Do you maybe want to?
Yeah, happy to. Yeah, so I saw this and I thought this was awesome because he's standardizing basically the liquid measures onto ounces. And so it's doing all these different conversions, and he found that the conversion ratios here in order to get the equivalent. This is really cool, and I thought it was a good approach. I was interested because I saw Dave Robinson do something kind of similar. There's actually a package called Measurements on Crayon that'll allow you to do this in a very general form. So just take kilograms, convert it to grams, take milliliters, convert it to tablespoons. It'll do all those conversions for you, and you just feed it a character of the unit 1, character of unit 2, and then the value you want to change. So I haven't used that before, but I thought it'd be a really good application here. All of this is definitely appropriate as well.
Mm-hmm. Yeah, and I thought it was cool that he put in all that effort to figure out all those different conversions and write them out here. Definitely a lot of work that was put into this. So it's good to see.
And again, kudos for aligning everything really well. I don't know if he did that manually or did a styler or something, but that looks great.
Mm-hmm. For sure. And then he goes, all right, for all these cases, I know that I've converted them to ounces, so let's label these guys as ounces, and then for all those other cases, they're still units. So we were thinking that those might be like a lemon wedge or something like that you can't really, you can't convert a lemon wedge into an ounce. Or if you can, kudos, but...
The one on this part, I think we talked about it briefly, is because all these all of these different strings are actually ending up as ounces, so they're all ending as the exact same thing. You can actually do a little cheat with string detect where you can pass it a combined vector. So if you actually grab bottle, can, cup, dash, shot, fifth, all those different ones, and did a paste 0 with collapse, it'll actually let you do that as basically string detect units in that. It's a different syntax, but yeah. So units, and then if you had paste 0, a bunch of different strings. Exactly. And then at the very last, there's a collapse argument. And if you do, I don't even know what the character is called, but it's the straight line, whatever the straight line is.
Yeah.
And or.
Yeah. Vertical. I read that as or.
Yeah.
But that'll string detect can actually work with that, and it basically says if we find a unit that matches bottle, can, random, or whatever string you have in there, then return ounce. And so you could do that very compactly.
Mm-hmm. So I'll quickly run that so you can see what that regular expression might look like too. No, this one would be a sep.
Yeah. And I think you need a concatenate in front of the bottle, can, random.
Oh.
Maybe you don't.
There we go.
Yeah.
I can do it.
Yeah, perfect. Yeah, and so because there's no spaces, it will still treat those as basically individual character strings. I don't remember where I saw this, and I wish I could reference who I found it from, but that's been a huge saver for typing.
There we go. We can open a PR on Stringer and ask that you do the str detect or.
Exactly.
Write that underneath that. Boom. There you go. All right, so let me get rid of that addition just to make sure we don't mess up his code. And run this. All right, so now we've got everything that's converted to ounce. And what he's doing here is he does a quick check just to make sure that things are as he's expecting it to, that he only has ounces and he only has units. And he's converted it for 841 records. So that's a lot of records. So, wow.
That's a lot of good work for sure. This was a lot of effort to get it cleaned up like this.
Mm-hmm. Mm-hmm. So now he has his data set. Now he's ready to actually start doing some extractions and pulling out what he cares about, what he's interested in doing. Actually start creating the data for his plots. So first he takes converted to ounce. He says, okay, any cases where we've defined it as ounce, but the beverage is not alcoholic, get all those ingredients, group by the ingredient, and then for each of those ingredients, calculate the total number of ounces that are used across the data set. So it's summing all the potential cases where like orange juice is used in the data set and sums it all up. So we get a total, if we were to make every beverage in this data set, we would need this amount. That'd be a party.
Yeah, it's quite the weekend.
But you need this much orange juice in order to make each one once. Then he orders it by the total number of ounces that he has, so that way we are able to see the which ingredient is used the most. He then adds in the rank, which is defined by the row number since we're ordered by the total number of ounces, and then takes a head so that he only keeps the top 10 of those ingredients. So he only keeps the top 10 ingredients. And so if we take a quick peek at that, it looks like milk is the most frequently used thing in a non-alcoholic beverage.
It's a lot of milk in the aggregate.
Yeah. Yeah. It might be interesting to then add like how many drinks used milk.
What drink would use yogurt? I feel like that'd be incredibly thick to try and drink. I can't think of like when you would use that. Other than a milkshake, but
yeah. And it's an interesting spelling of yogurt as well. Like that's a very specific one. So I wonder if that's like one large drink.
Yeah.
Yeah.
That
maybe.
use a lot of yogurt.
Right. Yeah.
All right. And then he said water is more popular than he expected. People drink it. All right. And now he does the same process, but now for ingredients included in alcoholic beverages. So now he's pretty much got it here. Let's take a quick peek at that. All right. So I guess I alluded to this earlier, but orange juice is the most frequently used beverage across, or excuse me, we need the most orange juice of all things. Not vodka, not water, not sugar, but vodka in our alcoholic beverages. So interesting. I mean, I guess that makes sense. Orange juice is a pretty common mixer in cocktails. So, all right. So now he's got his data organized together. He's done all the filtering. He's converted everything into ounces. Now he's going to be plotting it. So to generate that final plot that we saw. So he takes the alk included data set, or alk inged. He sets his aesthetics. So the y-axis is going to be the ingredient. He's going to convert it into a factor using factor reorder, and then define the order of the ingredients based on the rank that exists, and the x-axis is the total number of ounces that exist, or total number of ounces. He uses a facet wrap to define by group. Wait a minute.
Yeah.
Okay. Yeah.
Yeah, that's right.
Yeah. So
Alcoholic versus non-alcoholic.
Yeah.
Yeah.
No, it's not grouped by. So this is alk ing, which is only for alcoholic beverages.
Oh, okay.
Oh, yeah, you're right. Oh, interesting.
So he's faceting by group. So there's only one group. So I guess this is so it can add that title at the very top.
Yeah, that's right. That's right.
Oh, sure, yeah.
Then he's defining the color. So he's adding a genome bar. So adding a bar plot. He's defining the color to be of the bar to be this color, which is a hex code, and stat is equal to identity. So this tells genome bar, use the actual value that I'm giving you. Don't try to surmise what it should be. Use the actual value that I'm giving you. He's using this legend none from the package that he wrote there. I'm assuming that's telling it don't put in a legend. And then he's telling it don't have any labels, so X and Y are blank. And he's adding the theme that he wrote to it.
That's awesome.
Yeah, so that's really cool that he's able to do that and that he has his own theme. Like, That's so cool. And then it looks like he follows the same process here, but this is for the non-alcoholic beverages. Oh, so what he's adding facet wrap with the groups, and now you have the non-alcoholic beverages ordered also by the amount used, by total ounces. This is using a separate color, separate hex code for the bar plot. He adds this little geome text in here because he noticed something when he was looking at it, that there's wine and it's not an alcoholic group. So
I just like I like the level of precision on the x-axis. He's like he's down to like 15 significant digits or something. It's amazing.
It's incredibly precise.
Yeah,
that is great. I just realized something also. I think it's because of patchwork, but he just basically piped a ggplot into another ggplot with plus, and I think that works because of patchwork.
Mm-hmm.
I have never done that before, but that's what it is. That's really cool.
That's really smart. That's really cool there. Yeah, we didn't even notice that. Wow.
Yeah, because I've only ever done it like define like plot 1, plot 2, add plot 1 to plot 2 with patchwork, but I didn't know you could do it like on the fly. Makes sense, but yeah, that's great.
Yeah, for sure. Huh? I was wondering how that worked. I saw it happen in the output, but it didn't connect.
Exactly. I was looking at the code. It's like, how does that even work? And I was like, oh, patchwork is up there. That's really cool.
Yeah. So then he is defining. So yeah, he's defined where that text is going to go. He's got a lot of defining for that geome text, like what the text family will be, the color of that text, font face. So lots of work went into that little label there. Also telling it to not have a legend. Also don't have any labels there. Add the theme that he wrote. And then now I think because of this plus, now he's got this theme there, so he's setting the margin for the plot. And now he's adding plot annotation. And so this is going to be the overall information, because now he's patchworked together the two different plots, but they don't have titles, they don't have any information telling you how they're all related to one another. And that's what he's doing here. So he adds a subtitle defining, all right, these are the top 10 ingredients that I have. I thought it was interesting. He's using HTML in there, and this will come up in a second. But he's defining the color to be the alcoholic and non-alcoholic, those strings to be the color of the bar plot. So I thought that was really interesting. The title is What Do I Want? Surprise me. He has a caption. Of course, you always want to state where the data came from, and then he's adding his own label there, saying this is mine. He's defining the theme as well as the margins and whatnot. This bit here is what powers this subtitle. This is from the GG text package, and this tells it to treat this as markdown and evaluate it as such. So let's run that. And if we give it a second, we will get the output that he has in theory.
Something I'm thinking about while this is all running is because he did it intentionally as like two separate graphs and combined them together. There was duplication of a lot of the custom theming stuff he did. Mm-hmm. For some one-offs, like you can actually define that as like a theme at the very top and just basically add that to both of them. So you could just, save it once and then add it to both as like, theme temporary or whatever.
Gotcha. All right, let's give my computer a little bit more time. It's really struggling today. I'm sorry, guys.
It's okay. This one's worth the wait. It's a good graphic. You can also go to his Twitter post that has the graphic there.
That's a good idea too. All right, let's do that. Let's just do that. Let's faster.
There we go.
There we go. It's going to bring it up in the larger format. Will it? Hopefully it will. There we go. All right. So, though we are missing that little label,
right,
that he had there, but
there's a lot of effort. There's, like you said, 94.2999 all the way through. So a lot of effort we don't ignore.
No, want to call that out. That was really cool. but yeah, so there's a lot of really cool elements here. He's coloring the words alcoholic and non-alcoholic to match the two different bar plots, which I think is a great way to visually help tie together, what you're trying to show. The scales look great. The theming is, I think, very pretty. And yeah, I mean, Thomas, Patrick, do you have any final thoughts about this?
I think it's pretty cool. He did a follow up one in another, in a subsequent chunk. I think you can see it down there in the bottom right. I believe it's like buy drink or something like that. I think he had like a follow up one. Same concepts, just applied to different information. But yeah, I think it looks really nice. It's a good color, easy on the eyes. Yeah, pretty cool.
Yeah. I really liked, this is very clean data viz, and I always like that. And then so much effort put into the data cleaning. I think that's worth, highlighting from the whole post.
Definitely.
Yeah, for sure. That's awesome.
All right.
Love it.
Thank you so much, Joshua, for letting us go through and explain how your code worked. I found it really valuable to go through that and explain it, and we had a great time doing it. So... yeah. All right, so now we're going to move on to a new piece we've not done before, where we will be talking more with Patrick. So let me bring up, with Thomas. So let me just bring up our little Jitsi that we've got going here. All right, so now you actually see our faces too, because... I guess we've never actually shown our faces before. So I'm Ellis.
What up? There we are.
Here we are.
In our glory.
All right. So let's just start a conversation. Let's just talk. So Thomas, I guess. So why did you start Tidy Tuesday? Like, what was your thought behind this project?
Yeah. I think it was kind of twofold. Number one, it's like the R4DS online learning community. I joined as kind of like a mentor learner. Like I was definitely learning R at the time, and so massive thank you to Jesse for like starting such a great community and like creating an environment where people could help each other out. And kudos to John for continuing it on like today. Specifically to Tidy Tuesday, there was kind of this push back in 2018 to try and combine some type of mentors with learners. And so we'd worked as a group towards we create a project where people work together, get some feedback, and then kind of contribute to the community or learn a new skill. I think we initially tried to do this as like Tidy Month or like Tidy Week, where it's like longer form projects. But that required like a lot of time from both the mentor and then a lot of time commitment from the learner. And then Tidy Tuesday was definitely more like bite-sized learning, like kind of take it, go for an hour, go for 10 hours, like whatever you want, but you could get it done, relatively quickly or do a deep dive if you wanted to. And yeah, I mean, for me, it was more of like, I was already doing a lot of data cleaning and like trying to create portfolio items. And I was like, I wanted to make this process easier for whoever's next. Like, here's a bunch of data sets, create your portfolio, get a job or learn a new skill. And I think the community has like built a lot of like goodwill around that, kind of learning from each other.
Definitely. It really helped me back in 2018. I was able to create a portfolio online on GitHub from Tidy Tuesday projects. Awesome. And that actually helped me get my current job. So thank you so much for putting this together. It's been a huge help for me. Patrick, do you have any?
Yeah,
you said you had a few questions.
How far ahead do you work on the data sets? Like, are you 4 weeks ahead you've got data for, and then how long are you spending on cleaning it before you kind of make it available to the world?
Yeah. I'll just say that there's some weeks where I've got the data prepped and it's been ready to go for a while, and there's some weeks it gets done Monday morning. So I can't promise either way, but I've tried to be more diligent about like at least getting it done well ahead of time so that like I can post it Monday morning. That's usually my goal. So that people who are not in the US, like they're in UK or wherever else, it's easier for them to get started on it on Tuesday, as opposed to if I post it Monday night, it's Tuesday afternoon and everyone's working. So for that, I try and get it ahead of time. As far as time spent, again, that's a huge spectrum. There's some data sets like this one. I did some pretty small pivoting just to get it from wide data to long data, and then intentionally left it really messy. So that was relatively quick. But there was some that take me 4 or 5 hours to get all the way through and do at least some like data validation. So yeah, it varies, but usually I can do it in like a weekend and get it knocked out.
Wow,
that's pretty cool. Oh, I gotcha. And you work for our studio, correct?
Yeah.
And but your PhD was in neuroscience. So somewhere are you done with academia? Is it like over? That's it.
That ship sailed probably 2 years before my PhD was done. Is when that ship sailed.
In neuroscience? What was your what was your thesis on? What was your thesis? Yeah.
Yeah. So I learned R like while I was doing my PhD. Before that, I'd been using things like SPSS or Systat, Excel, kind of the traditional academic stuff. And then around 2016, like year 2 of my PhD, I was just like, I don't want to do this as a job. Like I was doing animal behavior. I was like researching how mouse aging and like removing specific like antioxidant proteins negatively affected the lifespan. Like that's it in a nutshell. Is like there's oxidative stress or like damaging effects from like the sun or from like just breathing oxygen over time,
right?
Which is necessary. Like that's how your body works, but it causes like small damage to all your cells. And so we took out a protein from our mice, let them age basically for 2 to 3 years, which is like a normal mouse lifespan. Mm-hmm. And then did a bunch of like functional motor testing and cognitive testing. And that was fine. Like I had a great mentor. She was very supportive of like me trying to like get into alternative careers. But I just knew at year 2, like I did not want to run a lab and submit grants. Like grant writing and scientific writing was not for me. I'd much rather write blog posts and speak to data scientists. Yeah. So happy to kind of be where I am today. Weird journey to get here.
Yeah, interesting. And what's the future? Like where do you want to go 10 years from now?
Yeah, absolutely. So I think part of what I'm doing at our studio is like I work with our professional customers. So like if you think of like RStudio Server Pro, RStudio Connect, Package Manager, like all this stuff that kind of builds on all the open source work and allows you to like publish things out or share Shiny apps within an organization or the like. That's been a lot of fun, and I actually lead our high technology group at our studio. So all of my customers work in either sports or in what we consider high technology. And I don't think I can say like which companies, but if you could think of like a tech company doing data science, they're using our product for sure. So it's been really cool. Excited about doing that and kind of continuing. Hopefully, kind of down the road, we get more sports teams. That's always great for me. Like I have a huge love for all sports analytics. I try and stay involved with the NFL specifically. But we've done like women's tennis, women's soccer. We've done hockey. We've done Tour de France for Tidy Tuesday. So more of that would be great.
I mean, I always have a great time when we have the sports-related data on Tidy Tuesday. I have a good time seeing what we can do. And I know Patrick and I have a good time seeing what we can glean out of that.
Oh, yeah.
Well, sometimes it's nice to do other data sets, though. Get away from what you do all day. But yeah, right. It is. The sports ones are always fun. I love the powerlifting one. That was my first one.
Nice, yeah.
Being prompted by Ellis to make a contribution. The powerlifting one was my first one. So I was like, oh, that's kind of cool. So, but it's an amazing thing, what you said about creating sort of this repository of data for people to essentially have access and create something. Questions I always get from students are like, oh, how do I get a job like you do? And how do I, move on? Or what do I do when I graduate? And I'm honestly like, myself and lots of other people in my position got our jobs because we wrote blogs. And I'm like,
exactly.
it's like the easiest free market. Like it costs nothing to do. It's totally free except for time. And like, even when we interview people, it's like, bring examples of what you do. And like, it's amazing because people will be like, oh, let's say I'm really into sport. And they're like, but I've never worked in sports. So I don't have any data. And I'm like, if you're really into it, you find it, like you go and get it. And so I think, I do think the entire concept of Tidy Tuesday is just really cool because it just makes things accessible to people, to work on their skills and improve and learn, from others. Like I learned a ton a long time ago from watching David Robinson's, videos. Like, I mean, I was pretty much exactly as you described. Like I do stats in Excel and stats in SPSS. And when you do, research, it's like, you don't need to do anything else outside of, it's pretty easy when you've got 25 subjects. And
exactly. That's how many mice that happen to cohort.
Yeah, and it's like, oh, this is great, and everything's in a nice column and whatever. But yeah, I mean, once you get into like the real world, you realize like, oh wow, there's so much.
There's a lot of problems to solve.
Yeah.
Somebody didn't enter the data right, or
yeah. So I think
distracted.
it's really awesome.
Yeah,
Sure.
I definitely think with regards to like portfolio building, it's like, yeah, you can go as far as you want, like in terms of at the very least, like just showing like, here's something I'm interested in. It's much easier to talk about, like even if it's just like, analyzing Spotify lyrics or something. Like if you're really passionate about music, dive into that. It's gonna be a lot easier to talk about in an interview than I took like, Titanic and went through it. It's like if you're not interested in the data set, like it's much harder to get at it.
Yeah.
And then as far as the portfolio items, like it's great to hear, like Ellis, you said like this was big for you in terms of like learning for your job. I know of at least 2 or 3 other people that use like Tidy Tuesday portfolio work to get into the current job. And that's all like their effort. Like, the data set's up there, like that's fine. But all the effort that individual people put in to kind of like applying it in their own case really helps them.
Exactly. You can really tell when somebody's passionate about, what they're working on and what they're doing, because they just put in the extra effort. They have that extra context, and you can analyze Titanic again, like everyone else.
Right.
But it really shows that you can also think outside of the box too, by having this data set that a million of people haven't gone through in their introductory data science class. Yeah. You can apply the same concepts, but it's just you can really delve into it and show your understanding of context, because that is so important to data science. Is you can run the linear model on anything, but knowing what it actually means and whether the results are reasonable requires context.
Yeah. And there's nothing wrong with Titanic. I mean, that's totally fine. Like I definitely used Titanic years back, like when I was learning, but going into an interview, like I didn't bring it up. It was just like my personal learning. But if you have that portfolio item you've worked hard on, you're proud of it, like you can share it as a blog post, you can talk about it in interviews, and you're building skills. Like I think that's a great trifecta.
And speaking of learning, like what recommendations do you give someone who's never coded anything in their lives? Like, R looks cool and Tidy Tuesday looks cool and people make these fun graphics that I see on Twitter. What do I do? What is your...
Yeah, I think that the 2 parts are almost like lag behind in Tidy Tuesday. So either do it at the end of the week, so you get to like borrow from other people. You can like take their code and like break it down, or even do it like previous ones. Like if you use tidytuesday.rocks, that's a Shiny app at Tidy Tuesday /rocks, and that has all the past submissions. And if you go there, like you can pull out all of the ones like, oh, I'm passionate about this subject. Here's all the ones I'm interested in.
Oh, yeah, sure.
The other part is like the R4DS book, like R for Data Science. That's free online. It basically is an entire course of like how to get started in R, and it gets started with data visualization. So like you get to eat your cake a little bit first before you dive into like learning all the nuts and bolts. Like you get to do something and then start learning as you go. And that's usually my suggestion.
Yeah. Super cool. I wish it was around when I was learning R.
Yeah. My first time learning it a few years before I actually learned it was not fun. And it was just because it was for a stats course and we were doing it all in, I think R Commander, which wasn't as much fun.
Which is like SPSS and R.
Yeah, it was a little bit more rough.
Yeah, like that. I wish something like this was around. I remember when I learned R, I was like, okay, I got to just learn this. And at the time, I was working at the sports biomechanics research lab at Nike, and so
Nice.
I bought. Andy Field is this statistician in the UK, and he wrote
Yep.
this book called Discovering Stats in SPSS, and then he wrote Discovering Stats in R, which is like this 900-page like massive book. And like literally, my goal was, okay, I'm gonna grab like a massive cup of coffee and spend 2 hours in the cafeteria at Nike every day, just going like page by page, like how do I do this? How do I do that? And that's how I learned. And after about 500 pages, I was pretty decent. But it took a while to get there.
That's awesome. Yeah, actually, I forgot. I did some biomechanics back in undergrad. Like I did kinesiology in undergrad and then XPhys for masters. So
Yeah.
I wish I would have found R back then because like there was a lot more data than my mouse data, which was like 20 rows. But like that biomechanics data, you get thousands and thousands of.
Yeah, wearable technologies is like
totally.
It's really easy in a like when I was working for the national Canada national basketball team as an applied physiologist, like it's really easy when you got 100 hertz of an accelerometer and 13 players practicing for an hour and a half. Like you rack up some serious rows of data for sure.
All right. Thomas, so what do you see for what's next for Tidy Tuesday? Like, what do you see it growing to?
Totally. Yeah, I think that part of it is some advice I took from Jessie when I actually was talking to her about starting the project. It's just like giving people kind of the freedom. It's just like, hey, like this is really cool. Go and do it. Like you don't need my permission. Just go and do it. Like it's a community project. Like I'm super excited about Tidy Tuesday R, and that like you basically created like this perfect way of getting the data all into R very easily, and abstracting away some of the like raw.github.csv or whatever. And then like Neil Grantham put together like tidytuesday.rocks. So just like other people building up like subdomains of like how to use it. As far as like where we're going, I mean, I'm excited that people like Julia and Dave and Hadley just started doing like screencast, and I hope more people and like yourselves for TidyX start doing more screencasts. So it's just like you can kind of dive into it however you want to. Like one person doing it is probably not how every single person wants to digest it. Somebody wants a code walkthrough, like y'all provide that. Someone wants live coding. You have like Dave and Julia, and then Julia also writes a blog post. Maybe that's how you want to digest it. So I like how all those different things happen, and I hope that continues, like kind of growing naturally within the community.
Gotcha.
Cool.
Awesome. Well, I think that concludes all our questions that we have. I know I'm really appreciative of you spending your time to join us and go through and explain some code, and then bear with us as we ask you a few questions.
Great to be here. Then thank you so much for having me over.
And all your hard work in putting this stuff out. Spend a weekend to clean a data set for humanity. It's a labor of love.
Yeah, no, I will say that I really appreciate a lot of people have been actually submitting data sets. So you can go to Tidy Tuesday on the GitHub and submit it as an issue. And then some other people have actually been submitting entire Tidy Tuesday submissions where you like create a README, do some data cleaning, and submit the data that way. That's a huge amount of effort as well. So I don't expect like everyone to do that. But if you find a cool data set and you want to put it all together, you can submit it that way, and we'll use it down the road.
Interesting.
Awesome.
Yeah. Cool.
All right. Well, I think that concludes our screencast. Once again, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
I'm Patrick Ward. You can find me on Twitter at OSPPatrick.
Cool. I'm Thomas Mock. You can find me at Thomas_Mock. But yeah, thank you so much for having me.
All right. Thank you.
Appreciate it.
Keep on exploring your world.
See ya.